All right, let me do a quick lesson now. I know that was a bit to go over the homework, but I wanted to make sure you understood it. This will just take about 5 minutes. Most of what you'll do today will be like yesterday, but I'm going to add a little bit more information to your knowledge bank, so you'll do some things a little quicker and a little easier. So again, just to review, a reference angle is between 0 and 90, always formed with the x-axis. And the idea is that if we can figure out what one reference angle is, so if let me zoom in here for a second on this guy. So here, for instance, if I have this nice little triangle in quadrant 1 and its angle, whatever, 40, let's say, there are 3 other times. There's a time over here in quadrant number 2 that is 140, because 80 minus my 40 puts me in that quadrant, but I will generate the same answers for sine, cosine, and tangent, because the opposite's the same, the hypotenuse is the same, the adjacent is the same. The only thing that will change is the positive and minus, and I'll show you that in just a minute. Another time period where you'll get the exact same value or angle will be 180 plus the reference angle. So in this case would be 220, because that would be 180 plus 40. And that would put me in this particular quadrant 3. And those values will be the same for sine, cosine, as tangent as it did in the original one, which is super cool. So again, one angle, the reference, provides me knowledge in all of the quadrants. Finally, that would also happen here in quadrant 4, where it would be 360 minus the 40, so 320, would provide me the exact same answers as that original one. So that combination is important. The reference, 180 minus the reference, 180 plus the reference, and 360 minus the angle, the reference angle. And that will generate them for you. Now what happens when you do that is, let's say in this case, well, there's the 40 I was using. So there they are, 40, 140, 220, 320. Those angles, notice, all produce the same, excuse me for the yawn, the same sine value. There it is. But 2 of the times are negative and 2 of the times are positive. Now why would some be negative and some would be positive? Well, let's go back to those 2 places. If you're in this quadrant, sine would be the opposite. That's a positive value divided by positive, so it's positive. If you were in this quadrant, this y value is the opposite. It's positive divided by a positive is positive. Now, watch. In this particular arrangement, the y value is a negative y value divided by the hypotenuse, which is always positive. Sine becomes negative in this quadrant. Here, sine is also negative because the y value, which is our opposite, is also a negative. So negative divided by positive. So we learn that sine is always positive in quadrant 1 and 2, and sine will always be negative in quadrants 3 and 4. Now let's see what happens to cosine. Here are 4 angles that make up the same values, and this is the cosine value. And in quadrant 1 it was positive, and in quadrant 2 it's negative. And in quadrant 3 it's negative, and quadrant 4 it's positive. Let's look at each of those. So adjacent, which is the x value, is positive over positive. Got it? Now watch. The adjacent is negative here, and so that's why cosine is negative in this quadrant. It's also, adjacent is also negative here, so we have a negative answer in this quadrant. And notice the adjacent, or the value here, is positive again, and so overall it's positive. So we learn that cosine is always going to be positive in quadrant 1. And in quadrant 4. And the other 2 quadrants will be negative for cosine. Tangent goes positive, negative, positive, negative. Let's find out why. So tangent is the opposite over the adjacent, which is, in this case, our positive divided by positive. So it's positive. Here, it's a positive divided by a negative x. So that's why it's negative. Here, it's a negative divided by a negative. Negative divided by negative is a positive. And then finally, a negative divided by a positive is a negative. So we see tangent follows a pattern too. Now, you need to know these things, unfortunately. You need to know who's positive when. That's today's lesson, really. And the good news is there's an easy way to do this, called the cast rule. Now, some teachers refer to it differently than the cast rule. Some teachers start in quadrant 1 and say, all students take calculus. I don't believe that, so I don't use that one. But the advantage to all students take calculus is it starts in quadrant 1. Maybe it makes it easy for students. I use CAST, C-A-S-T, the CAST rule. And you just have to remember that C starts in quadrant 4. But what do these letters stand for? In quadrant 1, because the x and the y values are positive, everybody's positive. All are positive. Sine, cosine, and tangent. In quadrant 2, the S stands for sine values are positive because it's the y over the hypotenuse, which is positive. But tangent and cosine are negative because the x value is negative in that quadrant. So only sine. In quadrant 3, tangent is the only positive one, thus the T. And in quadrant 4, cosine is the only positive one, therefore the C, the CAST rule. So let me just show you how to use this a little bit, and then we'll let you work on some questions. The sine of 240 degrees. Well, where is that? That's bigger than 90. It's bigger than 180, but it's smaller than 270. So that puts us in quadrant 3. Tangent is the only positive one there. So sine would be a negative value. I would circle negative. How about the tangent of 175? Well, 175 puts me in this quadrant because 90, 180. And tangent would be negative in that quadrant. How about this question? What quadrants could I be in if this relationship was true? The sine of some angle gave me 0.55. Now, what really matters is the 0.55 was positive. So that means I must be either in quadrant 1 or I'm in quadrant 2, because that's when sine is positive. I would circle both of those. Next one says, name the quadrant which I think that this would be in. Now, sine came out to be positive. Cosine came out to be negative. Where would that be? Well, sine is positive here, but cosine would also be positive, so I'm not there. Sine is positive here, and cosine would be negative here. I must be in quadrant 2 to make that happen. Let's do one more of those. Sine could be negative, and cosine would be positive. Where would I be? Well, cosine's positive here, and sine is negative there. I must be in quadrant 4 if that's what took place. The last thing I want to show you is to use the quadrants to find some values. They're going to give you a location or a point, and you're going to be asked to find the sine, cosine, and tangent values for that point in time. Now, all you're going to do, let me see if I can bring up something to write on here. Let's just quickly say new to this. All you do is you're going to kind of create your little quadrant coordinate grid. We're going to go -3, that's our x value, and -4, that's our y value. This is the location, -3, -4. And here is my angle, my reference angle right in there. So I need to know the sine and the cosine values in here. Now, the sine value would be the opposite over the adjacent, opposite over the hypotenuse. So I need to know the hypotenuse. So we better do some math here real quick. But you know the Pythagorean triples. Minus 3 squared minus 4 squared equals x squared. We're going to find that this comes out to be a 5 when we do the Pythagorean work. And so now sine is the opposite. Let's see, this will go away in a minute, but this, actually, let me just do the answers here. The sine value would be an opposite, which is a -4 over a 5. The cosine would be the adjacent over the hypotenuse, -3 over 5. And finally, the tangent would be opposite -4 over -3, which is 4/3. I want you to notice something using our cast rule. In this quadrant, tangent should be positive. And look, tangent's positive, cosine is negative, and sine is negative. And so these would be the values I would write down. They don't ask you for the reference angle, but we could do that. You could do the inverse of one of these to get that angle value and to do that. That's plenty for today. We'll build on this tomorrow and again and Wednesday. Thank you for your patience. Keep up with me. Good work.